In this lesson, we are doing probability of compound events. We are determining if compound events are mutually exclusive. Then we want to find the probability if they are mutually exclusive. And then to find the probability of compound events that are not mutually exclusive. And finally, find the probability of an event using its complement. So mutually exclusive events have nothing in common, as you can see by the Venn diagram. So if we are going to find the probability of two events that have nothing in common, we simply add the probabilities. Let's take a look at an example. One 6-sided die is rolled. What is the probability of rolling a 3 or a 5? On a 6-sided die, there is one way to get a 3, and there is one way to get a 5. Since they have nothing in common, we simply add the probabilities together, which would be 2 out of 6, which reduces to 1/3, and that can be 0.3 repeating or 33 1/3%. In the next example, we have one 6-sided die that is rolled. What is the probability of rolling a multiple of 3 or a 5? Multiples of 3 would be counting by 3s, and on a 6-sided die there would be 2 of them, a 3 and a 6. The probability of rolling a 5 is 1 out of 5, and these are mutually exclusive because they have nothing in common. So that would be 3 out of 6, or 1/2, which is 0.5 or 50%. Here is a Venn diagram showing events that are not mutually exclusive. In other words, they have something in common. So if I simply add and find the probability of A plus the probability of B, I would be counting this intersection twice. So in order to calculate, we need to add the probabilities together, but we need to subtract the intersection, the probability of A and B, so that I do not count it twice. For example, we want to find the indicated probability and then state whether they are mutually exclusive. In this first example, this event is not mutually exclusive because there is an intersection. So to find the probability, we add the two together, 0.6 plus 0.2, but we need to subtract the intersection so that we don't count those items twice. So the probability would be 0.7. In the next example, the probability of A and B, the intersection, is 0%. So these events would be mutually exclusive, meaning they have nothing in common. So to find the probability, we simply add the two together, which gives us 34%. In the next example, we have one 6-sided die that is rolled. What is the probability of rolling a multiple of 3? That would be a 3 and a 6. Or a multiple of 2. That would be a 2, a 4, and a 6. Well, we can see that they have a 6 in common. So if we only counted that 6 once, we'd have a 3, a 6, a 2, and a 4. That gives us 4 out of 6, or 2/3, which is 0.6 repeating, or 66 2/3%. Using the formula that we had calculated already, this gives us 2 out of 6 and 3 out of 6, but we would have to subtract the 1/6 that was counted twice, and you can see that we're getting the same answer, which is 4 out of 6, or 2/3, which is 0.6 repeating, or 66 2/3%. Next example, one card is randomly drawn from a deck of cards. Find the probability of a jack or a heart. There are 4 jacks in a deck of cards, and there are 13 hearts in a deck of cards. But we do hopefully remember that one of the jacks is also a heart, and so we can't count that one twice. So that gives us a probability of 16 out of 52 cards, which is 4 out of 13, reduces. And that is approximately 0.308, which is about 30.8%, or about 31%. In a poll of high school juniors, 6 out of 15 took French class and 11 out of 15 took a math class. 14 out of 15 took French or math. What is the probability that this student took both? So we have 6 out of 15 students taking French and 11 out of 15 taking math, but we need to subtract the ones who took both. And that would give us then the ones that took French or math. So that would be 14 out of 15. So if we add the two together, we get 17 out of 15. We need to subtract the ones that took both, and that would give us the ones that took math or French. So it looks like that the ones who took both would be 3 out of 15, which reduces to 1/5, which is 0.2 or 20%. Next, let's take a look at the word complement. Complement, A prime, all outcomes that are not in A. So the probability of the complement of A is simply finding the probability of the event and subtracting it from 1 or 100%. So the first example, a card is randomly selected from a standard deck of 52 cards. Find the probability of the given event. We want to know that the card is not a king. Well, we can do this without calculating, simply by common sense. That if there are 4 kings in a deck, we would know that 48 of those cards would not be kings. Or using our complement, we take 1 minus the kings, 4 out of 52, and that leaves 48 out of the other 52 cards that are not kings. We can reduce that to 12 out of 13, which is 0.923, or 92.3%. Now, how about the card is not an ace or a jack? So there are 4 aces in the deck, and there are 4 jacks in the deck, and they have nothing in common, so that is 8 cards. But I do not want to pick an ace or a jack, so I'm going to subtract that, and that gives me 44 out of 52 as my probability of picking a card that is not an ace or a jack, which reduces to 11 out of 13, which is approximately 0.846 or 84.6%. One high school student requires students to complete 30 hours of community service to graduate. There are 156 different community service options to choose from. What is the probability that in a group of 5 students, at least 2 of them will be doing the same community service? So what we want to do is find out the probability of at least 2 of them that are going to be the same. So we can calculate this using our complement. We can take 1 minus the probability that all of them will be different. And the way that we do that is we take 1 minus, so we have 156 different community services out of 156 choices. And then the next student, they could pick, there would be 155 to pick from out of the 156, 154 to pick from the 156, and 153 of them to pick from the 156, and 152 over 152 over 156. That's going to leave us with 1 minus 0.937, which equals 0.063 or 6.3%, that at least 2 of them will be doing the same community service. In the next example, it says 2 6-sided dice are thrown. Find the probability that the sum is no more than 9. In other words, that the sum must be less than or equal to 9. To make things a little bit simpler, we can take 1 minus the probability that it's going to be greater than 9. which means it needs to be a 10, 11, or a 12. And that would be right in this area, which means there are 6 different ways that we can roll the die to get that, which would be 30 out of 36, reducing to 5 out of 6, which is 0.83 repeating, or approximately 83.3%, or 83.3 repeating percent. To review, we want to find the probability of an event that is mutually exclusive or that are not mutually exclusive. And if they're not mutually exclusive, we need to add the 2 probabilities together and subtract the intersection. We also can find the probability of the complement of an event by subtracting the event from 1 or 100%, giving us the complement.